Today we are starting our unit on weather. And I put this picture up here for our original slide just to show you some of the things that we'll be talking about. We'll be talking about pressure, so you see high pressure and low pressure. We'll be talking about fronts, and there's a cold front and a stationary front. We'll be talking about wind, about precipitation. So we'll be talking about all these different things. Before we do that though, we need to get a few basic definitions out of the way. So the first basic definition is climate. So we know the difference between climate and weather. Climate are just the average weather conditions for an area over a long period of time. And that encompasses things like temperature, humidity, wind, precipitation. So think of climate as, okay, what is it usually like? So you think about maybe April in Texas. Well, it's usually, a little bit warm, maybe some rain comes in. We see a map like this, the climate classification, it really does a broad scale view of climate. You see in the Sahara Desert, it's dry. Okay, obvious. You're going to expect it to be pretty much always dry. Texas, they say we're on the edge between dry and temperate. Okay, so we have kind of, dry, hot summers. Winters are a little bit cooler, a little bit wetter. Okay, so climate are just these average weather conditions, what you would expect it to be over a long period of time. Weather, how is that different? Well, those are just the day-to-day changes in the atmosphere. That's where you have weather forecasters, and they say, okay, tomorrow it's going to be a high of 80 degrees, or it's going to rain, or the winds are going to be 20 miles per hour. Okay, it's the day-to-day changes in the atmosphere, not what is it going to normally be like, what is it going to be now or tomorrow. And that's when we'll get into things like fronts coming and pressure systems. Well, it says day-to-day changes in our atmosphere. Well, let's get our definition of atmosphere. So what is an atmosphere? An atmosphere is a mixture of gases, suspended solids, and liquids that surrounds the Earth. Of course, other planets have atmospheres too, and even some moons have atmospheres. But it's just that mixture of gases, suspended solids, and liquids that surrounds the planet, moon, or Earth. Do you remember how our atmosphere formed? We talked about it a little bit during the space unit. Remember, it came from volcanoes. Back when the Earth originally formed and then re-melted after the collision with Orpheus, we had all these volcanoes. They belched out lots of water and other gases that eventually formed our atmosphere. Well, what makes up our atmosphere? Hopefully you know some of the main gases that comprise our atmosphere. Here you see a very simple thing. There are lots of gases in our atmosphere, but the majority of our atmosphere is made up of just two gases. You see the most common gas is nitrogen, 78%. Second most common gas in our atmosphere is oxygen, at about 21%. Then, like I said, there are lots of other gases too. There's argon, neon, helium, krypton, xenon. Most of them are in very small amounts or trace amounts. Main two, though, obviously oxygen and nitrogen, you add them up, and you get almost 99% of our atmosphere made of those two gases. Like I said, there are other ones that aren't even listed on here. You think of something like carbon dioxide isn't listed on here. Water vapor isn't listed on here. Okay, those gases can change in proportion a lot. Another gas that we're going to spend a lot of time talking about in this lesson because it's really important to our health, and that is ozone. Okay, ozone doesn't show up here on a very common list because there isn't much ozone in our atmosphere, but it's very important for us. So what is ozone? Ozone, very simply, is a molecule of 3 oxygen atoms together. So here you see a picture of an ozone molecule. It's just O3. Is that the oxygen that we breathe in? No. The oxygen that we breathe is O2. Okay, O3 is a different molecule, different characteristics than O2, the oxygen we breathe in. Remember, the properties of compounds are very different. So this will not help us breathe. If we were only breathing in O3, we would suffocate. Okay, we need the O2 also. Okay, so what does ozone do? Why is it important for us? What it does is it absorbs UV radiation from the sun. So you see in this diagram here, UV radiation comes in. It's going to split regular oxygen up into just two O's, one of those oxygens is going to join the O2 and bond and form O3, okay, ozone. The ozone is going to absorb the UV. It's going to split off an oxygen as it does it, and that then is going to combine with the O2 again and start this process over again and regenerate some ozone. Okay, but it's absorbing the UV rays. In this picture here, you see the ozone layer. We're going to talk about more of where it is when we get layers of the atmosphere. If you want to write it down, it is in the second layer of our atmosphere, which is called the stratosphere. Okay, so the ozone is found in the stratosphere. And I can spell that for you if you're writing that down. Okay, stratosphere. It is the second layer of the atmosphere. Like I said, we're going to be getting the layers of the atmosphere in a later lesson. But here you see the ozone layer. You see the UV light coming from the sun. There are three main types of UV rays. UVA, a lot of that makes it to the Earth. Okay, only about 5% is blocked. Think of things like sunburn. Okay, that comes from because of UV rays. UVB is a little bit more dangerous part. It goes a little bit deeper into your skin if it hits you. 95% of the UVB is absorbed by the ozone layer. And then UVC, luckily all of that is absorbed because that would be really bad for us. Okay, so ozone, O3 molecule, very important for us because it's going to absorb the UV light that's coming from the sun. And we don't want to have a lot of UV rays. A little is okay. We don't want a lot because it causes lots of bad things. And we'll go through what it does. Well, you might have heard of an ozone hole. And that's kind of really why we're talking about this. Ozone hole, kind of a simple phrasing. Ozone depletion is a better phrasing. But basically, our ozone, it was depleted. Okay, something destroyed a lot of the ozone on Earth, and that allowed a lot of UV rays to get in, and that's bad for us. And you see some diagrams here that show you some different years. Total ozone in Dobson units. So the blue means not much ozone in this case, going up to more in this color. This picture is kind of different, almost the opposite colors. The purple is very little ozone here, going up to the red being more. And you see they're mainly focused on the South Pole. Okay, that's where the ozone depletion was most common, around the South Pole. And you see it really was quite a bit different. You see the color change, okay, a lot different. So we lost a lot of ozone, which lets in a lot more UV rays. Luckily, not a lot of people live, in the South Pole or Antarctica, but that ozone hole can extend up, especially hitting Australia and other places. And if we have ozone depletion, over us certainly, that would be an issue too, that we would have more UV rays coming in. Now, why is it over the South Pole? We'll get to that, but first we need to know, well, what caused the ozone hole? So what caused ozone to be depleted? And the answer is something called CFCs. Okay, it's abbreviation. That's chlorofluorocarbon. Okay, so CFC stands for chlorofluorocarbon. And it is a man-made compound. Okay, it was originally made, I believe, by the DuPont company. Used in refrigeration. Okay, you might know the word Freon. Freon is a CFC used in refrigerators, air conditioners. Also, CFCs were used as a propellant in spray cans. So it wasn't like the hairspray or the cheese that came out of the can. It was what propelled that stuff out of the can. Okay, so if you had your hairspray or spray paint, something pushed it out of the can, that was a CFC. And it works very well for doing that. Problem is, CFCs destroy ozone. And here you can see what happens. So the CFCs, we produce them on Earth, and they go up into the stratosphere. And here's a CFC molecule. You see the chlorines, the carbon, and the fluorine. UV hits it, and it splits off a chlorine. Okay, the chlorine is the bad part of the CFCs. So it splits off a chlorine. The chlorine hits the ozone, and it steals one of the oxygens. So we're left with ClO and O2. Okay, Do either of those block the UV light? No. We need O3. We need the ozone to block the UV light. So these don't help. Well, then the chlorine can then break off from that and destroy another one. So now we have free chlorine, and we're back to O2. And again, the O2 does not help with blocking the UV light. And now we have our chlorine, and that chlorine can go destroy more. Okay, so this was a big problem. You see my little note here that we're actually getting better. That's kind of why I'm using past tense in a lot of what I'm saying. It's still important because it's still a problem, but as you see in my little comment here, it's getting better all the time. Okay, so we made these man-made things called CFCs. They went up into the stratosphere and they destroyed the ozone that allowed UV light to get in. Well, why is ozone depletion a problem? So what is lack of ozone doing? Well, some different things. One of the big things is sunburn, skin cancer. So here you see a picture of a melanoma. So things like malignant melanoma are caused by UV rays. This is a picture of a cataract. Okay, so in your eyes, cataracts are caused by UV rays. Okay, so they're definitely a problem. Wrinkles on your skin caused by UV rays, age spots, things like that. So ozone depletion, a huge problem. You don't want to have skin cancer, obviously. You don't want to have cataracts. Here's a current map showing the UV. So you see for US right now, at this time, this is January 17th when I'm recording this, very low UV getting in. Okay, very good. So you go outside today and you really aren't in much danger from the UV rays. Well, January 17th, it's winter time, we're not getting a whole lot of intense sunlight. Where would we be getting a lot of intense sunlight? Well, Australia. So let me bring up Australia's UV forecast for today. And you see, completely different. We are in extreme UV risk in Australia right now. Okay, a huge issue. Australia is a huge issue. Again, it's closer to the pole. You really need to wear big hats, lots of UV clothing in Australia. When kids have recess for school, they wear big hats when they go outside because UV rays are a big problem down there. Not as big of a problem for us here in Texas, again, because we're closer to the equator. Problem gets worse the closer you get to the poles because the colder weather allows the chlorine to split up the ozone molecules more easily. So we go back to this. I said, so ozone definitely a problem. What are some things that you can do to protect yourself from the UV rays if a lot of UV rays are getting through? Okay. Well, you see, with this, obviously, sunscreen. Okay, that's the big thing. Make sure your sunscreen, though, works for UVA and UVB. So read the bottle, make sure it says broad spectrum, blocks UVA and UVB. How are you protecting your eyes? Sunglasses. When you buy sunglasses, make sure it says, at least meets the federal standard for UV protection, UVA and UVB. It's better to get one that blocks 100%. The government standard doesn't block 100%, but most sunglasses, if you look at them, you can find them that'll block 100%. Wear clothes that block UV. A lot of the dry fit clothes, golf shirts especially, fishing gear especially, it'll have tags on it that says UPF factor. And you want something like maybe a UPF of 30 or a UPF of 50. And it will block a lot of the UV rays. You think it's on a lot of golfing gear and fishing gear. Golfing gear because golfers are outside for maybe 3, 4, 5 hours, baking in the sun. Also, fishermen, the water can reflect a lot of the UV rays. So fishermen, a lot of the fishing shirts and stuff have UV protection. A lot of tennis wear has UV protection now because people have realized this is a big problem. You want your skin to stay looking good. You don't want to get cancer. So a lot of now clothing companies are using this UPF protection factor to help people. Okay, so I keep using the past tense for this. that UV hole was doing this, CFCs were doing this, because things are improving. The ozone hole is disappearing. Ozone depletion is getting less and less of a problem. You see this projections. This is projections if CFCs had not been banned by the Montreal Protocol in 1987. So basically, we realized really in the 1970s that CFCs were a problem, and CFCs were destroying ozone, and that's an issue because then more UV light was coming in, and it was bad for us. So, like I said, we started banning some things in 1980s. 1987 was the Montreal Protocol, which banned CFC production. Since then, it peaked in 1995, so you can see this map here. So the CFC level peaked in 1995, and the percentage of atmospheric chlorine has been decreasing about 0.5 to 1% every year since its peak in 1995. So it is improving a lot. Projections are that by the year 2050, I've seen some that say 2045, that the ozone hole will have healed. Okay, so we're finally doing something right. Lots of times we hear about things that we're not doing well, we're hurting the environment doing this. This is something that we're actually doing better with. I like this projections if we had not banned them. You can see what it may have been like. So we had the 2009 and 20. You see the concentration getting worse and worse. So even in the United States and in Texas, it would have been getting worse and worse. If we hadn't banned CFCs and we kept on using them, the problems that like Australia has had, we would be having now. Going outside would be a much riskier thing without really protecting yourself against the sun. Okay, so that's my little spiel about that. We'll get to that air pressure on the next one. Make sure when you go outside, wear sunscreen, wear clothes that has UPF factors, wear sunglasses. Protect yourself from the UV rays because it damages your skin, it damages your eyes. Yes, the ozone is improving, but it isn't there yet. Okay, not really healed until maybe 2050, 2045. So still protect yourself, even when it's completely healed, as you saw in that the picture in the beginning. Still, some of the UV does make it through, even then. So make sure you're protecting yourself and your skin and your eyes. Okay, and that's it for our first lesson.